What does life mean for us ordinary people? Mostly we imagine either a person or something similar to a person, so-called humanoids. However, life also includes trees, animals, ocean dwellers, and even our houseplants. Moreover, right now life is literally teeming on your palm. This is a micro-world invisible to us, but very real. Sometimes it reminds us of itself with a runny nose, cough, and other illnesses caused by viruses and bacteria. It is certainly logical to assume that extraterrestrial life exists as well. This time, let's not go far into the universe, but take a closer look at our own solar system. Which planet comes to mind first in this context? Obviously Mars. But let's leave it alone for now. It's better to wait until the colonization of Crimea begins. Red planets, come on. In terms of the discovery of life, it would be a good idea to take a closer look at Jupiter's moons, especially the Galilean ones, namely Io, Europa, Ganymede, and Callisto. There is probably no life on the gas giant itself since the conditions there are too extreme, and the lack of a solid surface doesn't inspire much optimism either. But those aforementioned moons are quite real footholds for the emergence of life in its various forms. First of all the celestial bodies mentioned are spherical in shape, and their sizes are close to our moon or Mercury. Secondly, a failed star, Jupiter and its surroundings are often called a miniature solar system because it gives a lot of accumulated heat to its moons. However, the radiation levels on them are monstrous. Thirdly, we will exclude Io right now from the list of candidates for the search for life and focus on Callisto, Europa, and Ganymede. Why? Because just beneath the icy crust of these objects, scientists have long suspected the presence of a warm ocean. Let's get back to the lethal doses of radiation generously given by Jupiter to its neighboring objects. Can they stop life from emerging on the moons? It won't penetrate the subsurface oceans, since they're located beneath dozens of kilometers of ice crust. They're also not threatened by meteors that sometimes fall onto the surface of celestial bodies. Finally, the thick crust serves as a wonderful means of insulation. Thus, it turns out that the Galilean moons of Jupiter are quite a logical target in the search for extraterrestrial life. In the future, a mission is planned that will shed more light on the characteristics of these celestial bodies, as well as the conditions present on their surfaces and even beneath the crust. But we won't wait. Let's try to figure out what information we already have. So where do we start? Let's take a closer look at Europa, since it's often considered in the search for extraterrestrial life. Astrobiologists and astrophysicists are almost certain that there is a subsurface ocean on Europa. It's paradoxical that Earth's oceans, including the world ocean, remain largely unexplored. We don't really know what forms of life inhabit, for example, the Mariana Trench, but we are certain that even in geothermal vents, which provide extremely harsh conditions, there are permanent residents. Entire ecosystems of bacteria have been discovered. Chemosynthetic bacteria, which do not need to depend on the sun's energy because they feed through the process of oxidizing hydrogen and hydrogen sulfide that occurs in these vents. From this, scientists concluded that life could also develop in the hypothetical oceans of Europa, Callisto, or Ganymede. How do researchers imagine the subsurface ocean on Europa? It is quite possible that its characteristics are somewhat similar to Antarctica's Lake Vostok, where under a 4-kilometer thick ice sheet, there is a lot of fresh water, oversaturated with oxygen and heated by geothermal sources. Interestingly, the pressure in this lake is about 300 atmospheres, but scientists are confident that microorganisms could very well have adapted to such extreme conditions. So why not assume that life could also arise in Europa's ocean, and not just at the bacterial level? During this period, more complex organisms may have evolved. However, Europa's surface is absolutely lifeless. It's extremely cold, down to minus 200 degrees Celsius, and you can only see strange streaks, ridges, and mountain peaks, mostly made of ice. By the way, radioactive decay actually helps the potential development of life in this sense, since it heats the planet's interior, and tidal deformations have the same effect. Thanks to nearby Jupiter, scientists have also concluded that Europa's ocean may not only contain anaerobic life, which exists without access to oxygen, but also aerobic organisms, such as fish. After all, oxygen enters the ocean during tectonic processes that move the ice plates, or when an asteroid hits the surface and breaks the ice. By the way, one of the pieces of evidence for the existence of an ocean beneath Europa's ice is the presence of geysers that release giant jets of water vapor. The body of water is likely twice the size of Earth's oceans and 100 kilometers deep. Of course, all of this is speculation based on indirect evidence, so we might be in for a disappointment. Europa's ocean might turn out to be too cold and lifeless, or filled with something caustic and deadly. For example, it might contain too high a concentration of snow, which is sulfuric acid formed by the oxidation of the moon's interior by oxygen. But what about Callisto? Is it considered as a potential foothold for the development of life? It's not only being considered, but also seen as potentially suitable for colonization. However, that's only in terms of the formation of even the simplest bacteria. The conditions on Callisto are worse than on Europa and Ganymede. It's all about radioactive decay and tidal forces. The latter don't heat Callisto's interior, unlike Europa. Callisto is only warmed by radioactive decay, and that's not enough for microbial life to emerge. At the same time, it's believed that beneath Callisto's 150-kilometer thick crust, there's also an ocean made of salty water and ammonia, with a depth reaching up to 300 kilometers. There's another obstacle that makes scientists doubt whether there's any life at all in this vast body of water. The thing is, during the formation of any life forms, it's highly desirable for water to come into contact with solid rocks, as this is how it becomes enriched with important trace elements. Unfortunately, on Callisto, things are different. Its interior is mostly made up of ice under incredible pressure. Why is Callisto considered as a candidate for colonization, along with Mars? The fact is, the moon lies outside of Europa's radiation belt. In any case, it can serve as a base for processing and fuel production, as well as a site from which shuttles will launch to more distant locations. The geological stability of Callisto in this regard is an additional bonus. And finally, Ganymede. Why is it included in the list of objects with potential extraterrestrial life? This moon is the most similar to a planet because it's quite large. Its radius is 8 times that of Mercury, and it's twice as heavy as the moon. The surface of Ganymede is incredibly cold, minus 163 degrees Celsius, but its interior can be significantly heated as a result of nuclear decay. Where did we get this information? The Galileo spacecraft provided it. According to its research, Ganymede has a salty ocean beneath a 200-kilometer thick layer of ice. It is believed that this body of water is layered and contains several types of ice that can only form under certain temperatures and pressure conditions. In other words, Ganymede's ocean is somewhat like a layered cake, where the cream is represented by liquid and the layers are made of ice. This moon also has an atmosphere, although it is extremely thin. It is noteworthy that it contains oxygen, which most likely appeared as a result of the decomposition of water ice. Galileo also found sulfur dioxide, carbon dioxide, and trace organic compounds. It is possible that they appeared in the atmosphere from the subsurface ocean, but the exact mechanism of how this happened is still unknown. But what do all these studies give us, and why even attempt to search for extraterrestrial life, even at the level of prokaryotes? You might be surprised, but many scientists no longer question whether life exists beyond our planet. They phrase it differently. When exactly will it be discovered? Perhaps these are attempts to get rid of the feeling of uncertainty. It's uncomfortable not to know something, especially when you're living on a huge rock constantly spinning in the midst of endless emptiness. The stated goal is to understand how life spreads in the universe. This way, we can study the forms of life present on Earth more dynamically and in detail, as well as understand the fundamentals of evolution. What questions have remained unanswered since the beginning of humanity and will remain so for many millennia to come? They sound like this. Where is the edge of the universe? Is it infinite? How can we answer these questions? Surely the most effective solution is to take a journey into the unknown and see for yourself whether the macrocosm has any boundaries. Unfortunately, modern technology only allows us to do this easily in a virtual way, but we are not lacking in imagination. So let's move forward. Deep space flights are an expensive and dangerous undertaking. In order to simply leave Earth's atmosphere and reach about 400 kilometers, the level of the International Space Station, you need to prepare for years, not to mention the technical side of the issue. However, Jules Verne once said that what is imagined by one person can very well be brought to reality by another. So let's assume we have an immortal crew that has undergone years of training, including stress resistance, and also a starship capable of at least reaching the third cosmic velocity in order to overcome the gravity of the solar system and leave its boundaries. The third cosmic velocity is about 16.6 km/s. Currently, probes achieve this by leaving the heliosphere's boundaries. An interstellar shuttle should be equipped with ion, thermonuclear, atomic, impulse, and plasma engines, and possibly solar sails. To ensure the survival of astronauts in harsh cosmic radiation, it is necessary to implement protective shields and other protective technologies. Such a ship has not been built yet, but let's imagine everything is ready for interstellar flights. We already have perfect life support and thermal regulation systems, advanced communication tools, an inexhaustible energy source, and reliable armor against relic radiation. So as Yuri Gagarin said, let's go. First, we will leave Earth, crossing the Kármán line, the conventional boundary between Earth's atmosphere and space, located at an altitude of 100 kilometers. We'll keep rising higher, constantly asking ourselves whether we can survive this deadly journey, whether we will find the edge of the universe, or if we are forever doomed to wander through unknown dimensions and voids. In recent decades, there have been repeated attempts to leave Earth, establish a presence in its orbit, and organize missions to nearby celestial bodies. And we have made some progress in this, but the path has been difficult. Remember the terrible disaster that happened in 1986 with the Challenger shuttle, which had an ordinary teacher from Boston among its crew. An engineering error turned the shuttle into a multi-ton bomb even before it left the atmosphere, and its wreckage, along with the lost crew, fell into the Atlantic Ocean. Now imagine what dangers await a person in outer space. Any force majeure or design flaw will lead to the complete failure of the mission and the inevitable death of the crew. But it's too late for regrets. We've already left Earth and are heading toward the edge of the heliosphere, beyond the Kármán line. The astronauts will feel Earth's gravity leaving them in weightlessness, where familiar physical laws become blurred and lose their relevance. Earth's atmospheric layers slowly dissolve, making radiation harsher. Because we are entering the Van Allen belt, a region of the magnetosphere where high-energy charged particles, gifted to us by the sun, are trapped. This region, deadly for astronauts and life-saving for Earthlings, begins at 4,000 kilometers above our planet, and the radiation belt ends at an altitude of 17,000 kilometers. The values are approximate, since the layers do not have clear boundaries. The space shuttle will pass through this layer relatively quickly and head toward the exit from the heliosphere, an imaginary sphere made up of solar wind plasma that protects our system from the dangers of open space. It must travel a long way, 18 million kilometers. We will see neighboring celestial bodies that were previously observed only through telescopes or by the eyes of probes. From Mars to Neptune, we will cross the asteroid belt located between the Red Planet and Jupiter, where we will learn to maneuver skillfully. And that's just the beginning, because beyond Neptune's orbit, a real monster is lurking. The Kuiper Belt is 200 times more massive and 20 times wider than the one we just passed. But what kind of challenge awaits the astronauts ahead? Failing to overcome it could bring a tragic end to their journey. And this is the boundary of the shockwave, beyond which the solar wind loses its supersonic speed and mixes with interstellar matter. Only here do the astronauts begin to understand what they have agreed to, and also realize the vastness and monstrous size of the universe. A system about which we know almost nothing. The solar wind entering interstellar space. In terms of scale, it's like releasing the contents of a regular syringe into a swimming pool the size of Saturn. The temperature at the boundary of the heliosphere is much higher than on the surface of the Sun, so the shock is going to be quite intense. But let's assume the ship's cooling and protective systems didn't fail, and the shuttle with live astronauts made it beyond this protective shell. By the way, if it weren't for the heliosphere, life on Earth would hardly have arisen due to the unshielded exposure to cosmic rays. What happens next? Total darkness, where the ship will travel for 3 centuries. Perhaps space adventurers will encounter one of the Voyagers from the late 1970s, hopelessly drifting into nowhere. There will be more and more comets along the way as the shuttle enters the Oort cloud, a giant region located a light year away from the Sun. All the belts we've passed will seem like child's play compared to this abyss, only after crossing the Hill sphere, the outer boundary of the Oort cloud. Technically, the astronauts will finally leave the solar system. Maybe we should turn back, because it's obvious that ahead lies only darkness and horror, even in the Oort cloud. Dodging comets and small celestial bodies, the shuttle has a certain chance of being destroyed at any moment. However, if the astronauts survive this ordeal, they will see the sphere of our galaxy, the Milky Way, from the outside. It will seem to them that nothing more beautiful can exist in the universe. But that's an illusion. It gets even more interesting further on. Would you like us to list the kinds of objects and phenomena on the way to the edge of the universe that could kill you? Asteroids, comets, pulsars. The main antagonists in this world are black holes. Even gamma ray bursts produced by the active cores of neutron stars are no match for them. Such a monster lives right at the center of the Milky Way, and its name is Sagittarius. And this black hole is the heart of our star cluster, which consists of 400 billion stars. Its mass is 4 million times that of the Sun, and its size is as large as the entire solar system. What if astronauts like Matthew McConaughey from Interstellar are overcome with curiosity and want to fly closer to the prototype of Gargantua to take a good look at it? It's better to push those dangerous thoughts away and step on the accelerator as hard as you can. It's not guaranteed that a wormhole exists inside a black hole's mouth. Most likely, if unimaginable radiation doesn't destroy the ship, then extremely high temperatures will finish the job. No one can predict what will happen beyond the event horizon or what the concept of spaghettification actually looks like in practice. And so the astronauts find themselves outside their home galaxy, beyond the Milky Way. The spaceship is awaited by myriads of stellar superclusters and separate clusters. Which one will we encounter first? Of course, the Andromeda Galaxy, since it's our closest neighbor, and in 4 billion years the Milky Way will have to merge with it. Does it seem to you that we've been flying for too long? Maybe the edge of the universe is already near. You couldn't be more critically mistaken. The objects we were talking about are just tiny parts of larger clusters. Both the Milky Way, Andromeda, the local group of galaxies, and even the gravitational anomaly known as the Great Attractor. These are components of the Laniakea supercluster, which is about 520 million light years in diameter. In Hawaiian, this word means immense heavens, and that's the most accurate way to describe it. These are just our superclusters. According to astronomers, there are about 100 such large-scale structures within 1 billion light years around Earth. Can you imagine the distances astronauts would cross seeking the universe's boundaries? Inside the superclusters, they will encounter hundreds of black holes that consume everything that falls under their influence, supernova explosions, as well as vast voids, great empty spaces, from which ominous sounds occasionally reach us. All these events, which are absolutely ordinary for the universe, can easily destroy not only a defenseless shuttle, but entire galaxies as well. What thought will come to the astronauts' minds at this stage? Was it all for nothing? Physical isolation, monotonous scenery, lack of clear orientation in space and time, and psychological tension, all of this doesn't contribute to a positive mindset. What will be especially difficult for the astronauts is not seeing their home planet on the horizon. Realizing they are extremely far from home can cause severe depression and even suicide. A grain of sand in the vast cosmos, absolute emptiness, infinity, these concepts will lose their abstractness and become reality for the lonely astronauts. So, is there a boundary where the universe ends? To answer that, you need to understand what the global structure is. We can only observe the metagalaxy, the observable universe, starting from the moment of the Big Bang, the theory we cling to like a drowning man to a straw. The diameter of the metagalaxy is 93 billion light years, but every year it increases by exactly 1 light year. That is, the cosmological horizon is gradually moving away from us, and the universe is expanding. Regarding knowledge of the macrocosm, people in the 21st century are similar in this way to those who truly believe the Earth was a flat disk resting on 3 elephants and a turtle. However, to quote Yesenin, face to face you can't see the face. The big picture is seen from a distance. But even using powerful telescopes, we are unable to comprehend the depths of the universe and see its real boundaries. What might the universe look like? Perhaps it is cyclical, and after heat death, it is reborn again through a big bang. Or it consists of billions of spheres, each with its own physical laws. Maybe right now we are just a step away from the boundary of a parallel world that we cannot comprehend. There are countless theories. Years of observation show that matter and substance are distributed relatively evenly throughout the universe, which suggests that the macrocosm may be infinite. But in that case, what awaits astronauts who decide to search for its boundaries? There is another side to the problem. What if the universe has the shape of a hollow Dyson ring or a closed circular labyrinth? How surprised will the travelers be when, after thousands of light years, they return to the starting point of their journey? Such a fiasco has never happened before in human history. Finally, let's present a strong argument in favor of the idea that the universe does, in fact, have a boundary. If we assume that it is infinite, then this parameter applies not only to space, but also to time and the number of objects. That is, our sky would shine brighter than the sun around the clock from countless stellar dances. But that's not the case. Currently, research is being conducted involving sound waves, which may help solve the mysteries of the edge of the universe. Also, after measuring the approximate full distances between galaxies, astronomers discovered that the macrocosm is asymmetrical, and this also supports the existence of a coveted universal boundary. However, it can be said for certain that if it has a shape, then there must also be an edge. Another question is what lies beyond its limits, and should we even strive to go there? Maybe we shouldn't try to disturb it. If you have any revolutionary ideas on the topic, be sure to share them in the comments. Who knows, maybe the scientific community will listen to them. Everyone knows what hell is, even if we've never been there. How do you picture it? Can we see what fills hell while still alive? Don't be quick to categorically deny such a possibility. It's better to take a closer look at the new images of Mercury and listen to its monstrous sounds. Isn't this an illustration of the fiery Gehenna? Could there really be even more terrifying and inhospitable places? Mercury is probably the strangest and most unusual planet in the solar system. If you think that the Atacama Desert is the deadliest place where it's impossible to survive due to the complete lack of rain and incredible temperature swings, think again, because once you learn about the conditions on Mercury, this place will seem like paradise to you. The fact is that temperature swings on Mercury reach 600 degrees Celsius and are the most impressive in the solar system. Here, there can be scorching heat reaching up to plus 450 degrees Celsius, turning rocks into molten lava, while in the darkness, temperatures drop to a deadly minus 200 degrees Celsius. Why does this happen? The planet is too close to our star, but that's not the main cause of the temperature swings. Such a huge difference is recorded due to the actual absence of an atmosphere. For the same reason, Mercury's surface is completely covered with craters. There's simply nothing to stop asteroids and meteorites expanding onto the planet. By the way, this is what one of the craters looks like, called the Callisto Basin, or the Plain of Heat. The width of this crater is 1,500 kilometers. What could have left such a giant scar on the surface of the planet? Scientists suggest that about 4 billion years ago, at the dawn of the formation of the solar system, an asteroid about 100 kilometers in diameter crashed into Mercury. The explosion was incredibly powerful, you could say monstrous, as if 1 trillion megaton bombs went off at the same time. News channels on Earth would have paid a lot to capture such an event. The Callisto Basin is the largest crater on Mercury and in the solar system. Just think about it. If you wanted to, you could fit the state of Texas inside it. It was Messenger that studied the Callisto Basin quite thoroughly. He clarified its size, took numerous pictures, and discovered an amazing formation called the Pantheon Fossae. There are no analogs to these strange narrow depressions found in the Callisto Basin anywhere else in the solar system. How did they appear on the surface of Mercury? Perhaps this was facilitated by the release of material to the surface, but the hypothesis is still very raw. Instead of a single tectonic activity, such as earthquakes or volcanism, Mercury has nothing to boast about. It is believed that these processes ended there about 3.5 billion years ago. The grooves are about 1 kilometer wide with around 230 in total. When and why these cracks appeared here is still a mystery. Perhaps the Bepi-Colombo spacecraft will solve it. It is set to arrive at Mercury in fall 2026. Among the many tasks assigned to the probes being sent into orbit around the planet, the main one is to map the surface of Mercury and study its geological history. In the meantime, would you like an interesting observation? Do you know which celestial body the tiny planet, scorched by the sun and named after the Roman god of commerce, most closely resembles in appearance? Strangely enough, it resembles our moon. Mercury's surface also has many craters. It's just as lifeless. And although it does have an atmosphere, it's so thin that it can practically be considered non-existent. It's remarkable that although Mercury is smaller than the Galilean moons in diameter, it significantly surpasses them in mass. This is all due to its high density, which is only slightly less than Earth's. What could this mean? To answer this question, you don't need to be an astronomer, just use logical thinking. Most likely, Mercury's rocks are rich in metals. Who has studied this planet and when? Are we still relying on data seen through prehistoric telescopes? Of course not. In 1975, Mariner 10 took photos of Mercury, and from 2008 to 2015, the Messenger probe closely studied the planet, ending its mission with a spectacular crash onto Mercury's scorching surface. Unfortunately, this epic event couldn't be observed from Earth, since the probe crashed on the far side of the planet. It's believed that the probe's wreckage is somewhere near the Janacek crater. Take a closer look. Maybe you'll notice something. What else did the Messenger discover during its years-long journey around this mysterious planet? First of all, it debunked the myth that Mercury supposedly has no magnetic field. Actually, This fact was confirmed by Mariner 10, and the second probe clarified the data. The messenger sent data to Earth revealing Mercury's magnetic field is 3 times stronger in the northern hemisphere than in the southern, varying by hemisphere. Astrophysicists believe that this is due to the iron core of Mercury transitioning into different physical states. Compared to Earth's magnetic field, Mercury seems insignificant, but it is capable of directing solar plasma straight onto the planet's surface and sustaining solar wind activity. What other facts about Mercury are astonishing? Definitely, it's the speed of its rotation around its parent star and the length of a day on this planet. So, a Mercurian year is 88 Earth days. This means that the planet flies around the sun at a speed of 180,000 kilometers per hour. By comparison, Earth orbits its star at 107,000 km/h, traveling over 2.5 million kilometers daily. But a day on Mercury is equal to its year, and this truly unique phenomenon is explained by astronomers as the tidal effect of our star. By the way, despite the extremely unfavorable conditions on Mercury, it is believed that there may be deposits of ice on its surface. In any case, radar studies of areas near the poles clearly indicate this. How could ice exist on the scorching surface of the planet? It is believed that comets, which sometimes visit Mercury, are to blame for this. The water from these celestial visitors evaporates at such extreme temperatures, but some of it still ends up in Mercury's permanently shadowed craters. Not a single ray of sunlight has reached these dark locations for billions of years, so the ice here can remain preserved for as long as it needs. The permanently shadowed craters are believed to be located in the so-called dark zone near the poles, where, due to the planet's rotation, sunlight never reaches. Did you know that even biblical miracles are actually demonstrated on Mercury? Here, you can observe the effects of Joshua, the character who, according to religious legends, once stopped the movement of the sun on Mercury. This miracle has come true. Our star behaves absolutely bizarrely in Mercury's sky. At first, it describes an arc across the sky. Then, right after sunrise, it stops. This happens at certain latitudes. Then it moves back and sets at the same point where it rose. This period doesn't last long, but it does happen. If we were on the surface of Mercury, we wouldn't believe our own eyes. If the characteristics of this extremely strange world didn't scare you, to be honest, they make us wary, just like the sounds Mercury makes. Yes, you heard right. A track was generated that characterizes Mercury's voice. It's something calming, but at the same time unsettling and echoing. That's how sensitive instruments hear the sounds of the planet's atmosphere and interior. It's a kind of mix of white noise that imitates radio interference, the breathing of some unknown monster, and a cacophony of voices from the abyss. Perhaps it was these very moans that the workers at the Kola Super Deep borehole heard before they shut down operations forever. But let's continue. What else can the mysterious Mercury do to surprise the average person? As mentioned earlier, there are more than 420 craters on the planet's surface. We've already talked about the largest one, but it's also worth mentioning the most prominent one, meaning the Kuiper crater. It's not known for its size, although the crater isn't small. Its diameter is 60 kilometers. Kuiper crater is known for its bright white color. It's impossible to miss on Mercury's surface, even when approaching the planet. For example, the image you just saw was taken by Messenger from a distance of 7,000 kilometers. In fact, at the moment, this orbital station is a real record holder, since about 280,000 images of Mercury have been taken during its operation. Among them were areas that had never been seen by anyone before. Also, Messenger came closest to the planet. The minimum approach distance was about 230 kilometers, which is almost twice as close as the International Space Station is to Earth, and 100 kilometers closer than Mariner 10. Is it possible to survive in this hell? Anyone who watched the video would say no, and they'd be right. You might be surprised, but Mercury is one of the candidates for terraforming or at least colonization, although it's definitely not at the top of the list. Because for proper terraforming, you first need to move Mercury's orbit about 30 million kilometers farther from the Sun, and also carry out a highly precise asteroid bombardment. That's trivial. Colonization is a more realistic task. The thing is, Mercury is believed to have a huge amount of valuable resources, particularly helium-3 and various metals. Thus, the planet could become a staging point for sending shuttles into deep space. Scientists believe that the colonization of Mercury could be similar to the process on the Moon. Possible ice deposits at the planet's poles are also a significant advantage for colonization and even terraforming of the celestial body. And the magnetic field can provide decent protection from solar radiation. It can't be said that there are no drawbacks to this plan. Take, for example, the endless days and the extreme difficulty of flying to Mercury. The resources and energy required for it would be almost the same as for a journey to Pluto. I wonder if the announced plans are feasible, and how many millennia would it take to accomplish them? Probably it's time to stop fantasizing before it takes us even further into the distant future. And in the comments, you can continue the discussion about how to tame Mercury and what might come of it.